Hey guys, so we're going to today talk about finding the values of the 6 trigonometric functions of an angle that's in standard position if we're just given its terminal side. So last time we looked at angles that are on the unit circle, but now we are going to look at angles that start at 0 and then they give us a point where they end, so maybe out here somewhere. And from that point, we can calculate what the different values would be for sine, cosine, tangent, cotangent, secant, and cosecant, okay? So our first example is find the 6 trig values for an angle whose terminal side is at the point -5 and 12. So I want to sketch the graph of this first. So let's see. 5, that works. Okay, so -5 and 12. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count by 2s here. So if I go back to -5 and then up to 12, that puts that point right there, right? -5. 12. So they're saying that's the terminal side of the angle, so that's where the angle ends. So I would connect that point to the origin, and that creates our angle, okay? So our angle is starting at 0, just like always, and ending up here. So this obtuse angle is the angle that we want to calculate the values for. Now, we don't know how to use SOHCAHTOA, your best friend there, for angles that are obtuse. We've only done it with an acute angle. So what we have to do is create what we call a reference triangle or a reference angle. So in order to do that, I'm going to take the end of that angle and I'm going to connect it to the x-axis, okay? And right there, I'm going to make, that makes a 90-degree angle where they connect. And so I've created a right triangle. In order to find the different values, I need to focus on an angle, and the reference angle we always want to focus on is the one closest to the origin. So theta is going to go right down there closest to the origin, okay? Now we don't know what that angle is yet. We can find it, but we know that that's the reference angle we want to look at to calculate the values for this larger piece, that larger angle there, okay? And we have 2 different lengths, right? So it's telling me that this angle ends at the point -5, 12. Well, that tells me that this side of the triangle, that x direction, is length -5. And yes, I'm saying negative length because it's going to tell us when we have negative values for our trig functions that our angle is obtuse and not acute. So the negative is important here, okay? And the y value tells us the length of this opposite side, which would be 12. So if we want to figure out what's the hypotenuse, that's our next step. Find the hypotenuse. So first we're graphing, second find the hypotenuse. We can do that, if we know 2 sides of a triangle, we can do that using Pythagorean theorem, right? So -5 squared plus 12 squared would equal to c squared. This is another one of your Pythagorean triples, so we would end up with c is equal to 13 here. That's the hypotenuse, all right? Now let's see if we can use that to help us find our different values with SOHCAHTOA, okay? So the sine of theta, we now know as the y value on the unit circle, but it's also always the opposite over the hypotenuse, all right? So from theta, from this angle down here, 12 would be considered opposite, 13 is hypotenuse, and -5 is adjacent. So the sine of theta is going to be 12 over 13, right? Next, I want to find the cosine of theta, which is going to be the adjacent over the hypotenuse. And so in that case, we would have -5 over 13. And then third, I want to find the tangent of theta, which we know as opposite over adjacent, which would be 12 over -5, okay? And all of those I'm going to leave as the decimals or the fractions. That's perfectly fine. So now let's go, excuse me, and find your other three trig functions. So first, let's find the one related to sine, and that is cosecant of theta. Now remember the other day we said that the cosecant is the opposite of sine. So if we do 1 divided by opposite over hypotenuse, that's the same as 1 times the reciprocal of hypotenuse over opposite, or hypotenuse over opposite. So if I really want to find the cosecant, all I have to do is reverse or flip or reciprocate the two ratios for sine, okay? So the cosecant here would be the hypotenuse divided by the opposite, which would be 13 over 12, all right? Let's bring these guys down a little bit. Okay, so similarly to sine, cosine is closely related to the secant of theta, sorry about the phone, and that would be the hypotenuse over the adjacent, so that's going to be 13 over -5. And then lastly there, tangent and cotangent are related. So if I want to find the cotangent of theta, it's the adjacent over the opposite, which would be -5 over 12. So easy as that. First find your SOHCAHTOA values, and then you're taking the reciprocals to find your other three trig functions. And then if we actually wanted to know that angle, remember you can use your inverse function. So if you did sine inverse of 12/13, that would give you an angle on your calculator. Again, make sure you're in degree mode. That would be the same as cosine inverse of -5/13 or tangent inverse of 12 over -5, right? There aren't inverse functions on your calculator for cosecant, secant, and cotangent. To do those, we'd have to do to do cosecant of theta, you'd have to do 1 divided by the sine of theta, which is really just more trouble than it's worth. So for actual calculation purposes, stick with your sine, cosine, and tangent, okay? And that's how you would find the 6 trig values for a point on